All right, so that was notebook 3. Let's move on to notebook 4. This is, we were previously looking at statistical relationships using line plots and scatter plots. Now we're using, looking at categorical data. So this is things like box plots, violin plots, or categorical scatter plots using strip plot and swarm plot. And these can all be accomplished using a higher level plotting interface called Catplot. This is another new one in the newest version of Seaborn. Or we can look at categorical estimate plots using point plot, bar plot, and count plot. So let's dig right in. So we're gonna set up our notebook with the packages that we need. And again, we're going to look at this TIPS data set. So by default, a cat plot will generate this kind of strip plot where we're just seeing all the data that are, and it kind of jitters them so that we can see all the points and we can get a good control or get a good view on the data. So if we want to remove that jitter, we can set jitter equals false, but then now we can't see the overlapping points. We could change those filled circles to unfilled circles, and that might allow us to see better what's going on. There's a related plot called swarm plot, which is super handy because this will, it's similar to having the jitter, but it kind of stacks the points more in rows. So depending on what you prefer, you have these options. So just like with the relational plots that we saw before, you can add categorical data using this hue semantic. So we can say hue equals sex and kind equals swarm, and we're going to get a swarm plot, but now we have the data separated out by this additional categorical variable. So if we wanted, we could also plot by the size of the party, and in this case we are removing size 3, so we're just showing a subset of the data. So we can do this on the fly. We don't have to specify the whole data frame. We can subset the data frame before we plot it. We could also specify the order of the data. So here we're saying we're going to plot if it's a smoker on the x-axis and tip on the y-axis, and then we can specify the order of those categories using this order operation. We can also view the swarm plot sideways, and just by changing the order of the categories, and then this time we're changing the hue that we're specifying. So there is a box plot function, but we can also use cat plot and say kind equals box, and this will give us a box plot. And so you guys are probably all familiar with a box plot. We have the median, and then the quartiles, and then these whiskers are 1.5 times the interquartile range, and then anything outside that is considered an outlier. If we want to, we still have the ability to use this hue semantic, which is really handy because now we can separate out our box plots by an additional categorical variable. Now, there's this really cool thing that they've added called dodging, which allows you to remove data that's not, remove categories that aren't present, so that you don't get like empty space in your box plot. So setting dodge equals false allows us to do that. So there's a few other styles of box plots. So we're going to use a different data set here called diamonds. And so now we have our x and y, and then this boxen plot is really cool. So it allows us to kind of box the data using these kind of sequential box plots. They kind of look like skyscrapers. So another way to look at distributions, in addition to swarm plots and box plots, is the violin plot. So here we have our x and our y data, and then we have kind is violin, and then the hue is time. So this will give us the distributions of the data separated out by time. So in the violin plot, we get the distribution overlaid on the box plot. So it kind of gives you the best of both worlds. And we have some options. We can cut off the ends of the, because oftentimes the violin plot will go past what's a reasonable value, just based on the distribution. So we can cut that off. And there's a few other parameters we can have control over. So we saw this in the gallery. So one of the examples or nice things about the violin plots is we can add, we can have a split distribution. So instead of having the two violin plots next to each other for these categories, we can have a split. So they're sharing the same plot. So this box plot in the center is for both male and female, but then the violins on either side are separated out by sex. So this is really handy. We can also have this inner stick, which will show you the individual points where they lie. So this is kind of cool. You can just get a different sense of where the data are using these black lines. Another way to show where the data are is to overlay a swarm plot. So this is actually two separate plots. We have a violin plot, and then on top of that we're plotting a swarm plot, and we can see where the data overlap. There's other options here. So we have the ability to look at, we can show error bars and measures of center. So that we're going to use this Titanic data set of all the people on the Titanic and who survived and who didn't. So we have sex and survival by first, second, and third class. So you were better off in first class, especially if, yeah. We can also show a count, which is like a histogram, and then it's just coloring based on just a sequential color map. We can also show that histogram sideways, so just depending on the order in which we supply the x and the y. and then subdivided out by class, so like the number of people in different classes. So another nice way to show data relationships is using a point plot. So this will, you'll have different categories on your x-axis, and then they'll be joined by a line on the between them that just kind of shows, helps your eye kind of keep track of where the data are, and then there are sort of error bars on the y dimension. So here we have, we can see first, second, and third class, survival rates for males and females. And we can also we can pass all kinds of additional data, so we can have palettes for males and females, different markers, different line styles in those point plots. So this just shows how to, yeah, just additional examples of how to show distributions in different kinds of data. So we talked earlier about facet grids and how nice they are to have. Basically, this gives you the power to view additional categories in your data. If you've already used different colors and different shapes and different positions on the y-axis or x-axis, you can create an additional subplot that shows an additional axis. So here we have the day of the week on the x-axis, and we have smoker or non-smoker by color. We can then use the column, which is the different subplot, for the time or the meal. So this is a really nice way to get additional information about the data. And if you want to have additional control, you can store that plot handle as a variable, which can then have additional options. So that plot handle can be has a set function, and we can set the scale as, say, log. So now we can set that x scale as log, and all that information now is, we have additional ability to customize that facet grid. Okay, and